class we talked about the fraction and decimal fraction. So today we'll talk about the percentage. So we'll first see how we can convert a decimal to a percentage. So decimal means decimal fraction. So it's pretty easy because we know that there is a decimal point. So all you need to do is, if you have a decimal, just move the decimal point 2 positions to your right. Okay. Remember, for an example, in this example, it's in 0.7. You can assume there are zeros. There are infinite number of zeros after 7. So all you need to do is just move the decimal place 2 positions to your right. Okay. So for an example, in 0.37, all you are doing is you are moving the decimal point 2 positions to your right. Then 0.37 becomes 37, right? And then you also add a percentage sign. I think most of us know the sign, right? Like this one. And now that becomes a percentage. So backward, if you have a percentage, how do you convert it to decimal? First, you have to remove this sign. And then you will move the decimal point 2 positions to your left. For example, we did the same one here. But be careful, let's say 3. So in 3, you have a decimal point just right after 3, right? And you can assume there are plenty of zeros, infinite number of zeros, in front of a whole number, right? In front of a whole number, at the beginning of the whole number. So all you are doing is just in in the 3, since you can assume like this, you are moving the decimal point from the right of the 3 to 2 positions to the left, which becomes 0.03. Okay? So that's how you know it's pretty easy converting it. So that means the percentage, decimal, and fraction, these 3 are convertible from each other. Okay, very easily. So straight. Any question here? Okay. Now we still have another one like the fraction. So we have already learned how to do the fraction and decimal fraction, right? How to convert between the fraction and decimal fraction in last 2 classes. So pretty much if you know one of these, either you know the percentage, or you know the fraction, or you know the decimal fraction, you should be able to convert the other one. Okay? Because let's say if you know the fraction, convert it to decimal fraction, and the rest is easy, right? You can move the decimal point. Right? So let's try some quizzes here. Let's convert 33% to decimal. The right answer is C, right? Because we move the decimal point to the left, 2 positions left, right? So the decimal point is right after 33 here, and we are moving it to here, right? 2 positions to the left. Right answer was C. How about this one? 5%. Convert it to decimal. Move the decimal point 2 positions to your left. Now you assume there are plenty of zeros in front of 5s, right? So that becomes 0.05. So the right answer is C again. 110%. How do you convert it to decimal? You move the decimal point again, just 2 positions to the left, and that becomes 1.1, right? Because the decimal is right after the 0. You move it 2 positions to the left, this comes here, right? And it becomes 1.1. And in case of fractions, you can ignore all the zeros at the end and after the decimal point. So instead of writing 1.10, you can just write 1.1. So that's how the right answer is B. Let's do the backward. So we have the decimal fraction here. How do you convert the percentage? Move to the right? 2 positions to the right, so it becomes 15. And whenever it becomes 15, this 0 is, it's not significant at all, right? So we just ignore this 0. we just write only 15. So the right answer is D, right? 15%. 75. 75%, right? So the right answer is A. This is a whole number, right? 2. You move the decimal point 2 positions to the right, but you assume there are plenty of zeros after the decimal point, right? So the right answer is 200%, because all you are doing is because you have two, and there are plenty of zeros, right? All you are doing is you are moving the decimal point 2 positions to your right, right? 1. You can move the decimal point. So you have decimal point where? Right after 1, right? Move the decimal point 2 positions to your right. This becomes 100. So 1 is 100%. So the right answer is B. 25%. 100%. Yes. Yeah. The last answer was 100%. Now, what is 25% if you convert it to fraction, decimal fraction? First you convert it to decimal fraction, and then you convert it to fraction. Okay? Now, remember, whenever you try to convert it to fraction, you always try to the simplest term, lowest term, right? Now, how you do it? Let's say you have 25%. So decimal fraction is easy because all you need to do is just move the decimal point 2 positions to the left and remove the percentage sign, so that becomes 0.25. Okay? Now from 0.25, this is your decimal, right? Decimal fraction. Now how you go to the fraction? All you need to do is just write 25. At the bottom you write 100 because there are 2 zeros because there are 2 decimal points, right? I'm saying decimal place after the decimal point. And then you try to simplify it down because you always want the lowest term. So maybe you can write 5 times 5 times 4 for 100. And you can write 5 times 5 for 25. And you cancel out the prime factors. You'll be left with only 1/4, right? Is that alright? So the right answer is what? D. Right answer is D here. So 50%. Let me give a pause here. Just try like how we did here and see whether you can find the fraction for this question. Okay, so what is the right answer? C, right? Half. Because it, So let's try another one. How about this one? Is this D? 300%. Move the decimal point 2 positions to your left, so that becomes a whole number 3. So the right answer is just 3. So you can write 3 as 3/1 because 1 is under everything because it's just a denominator. You can assume for every whole number. So the right answer is B. Okay, so let's see whether how we can solve some word problems using percentage. So in the word problems, you will have 3 different variables. One is called base, another one is called portion, another one is called rate. Now the base is something which is always something total amount, and the portion will be the fraction of the base. Now remember, even if it is a fraction, it may be larger or maybe smaller. So don't assume that the fraction means always smaller, okay? That's a confusion because you always think, oh, fraction means it's smaller. But fraction can be larger. So you say Okay, 150% of something, which is like more than the original, because anything can be at max as 100%, right? If I say more than 100%, it's pretty much like the portion would be more than original. So the base, so the portion can be more, and the rate is something which will be followed by the percentage sign. That will be a number, but that is a percentage. Now, let's see how we can solve different problems using these three parameters or three variables. Now, in any word problem, first identify these three. So remember, most likely you will be given 2, and you have to find the other one. You see what I'm saying? Let's say we give you base and rate. We say find the portion. We said base and portion, find the rate. Or rate and portion, find the base. You know, those are the things we do. So, important part is we need to identify what is given. It's always easy to identify the rate because it will be followed by a percentage sign. But sometimes it might be a little bit tricky to find the base or portion. Okay, so you have to read the question carefully to see which one is what. And then we'll be applying some formulas. So we have some formulas here. So, in fact, all these formulas are the same formula. This is the same formula, but we wrote it in different ways so that we can apply the formula whenever we need what. So, for an example, the first one, what is needed here? P is portion, right? So, portion equals to base times rate, which is exactly the same meaning we can write rate equals to portion by base. We can write base equals to portion by rate. Now, when we do what? We always work based on what we need. Now, let's say if any word problem, if the rate is unknown, other two are given, but the rate is unknown, which one will be using? The middle one, right? Because whatever you have unknown, that you left, isolated. If the rate is unknown, we'll be using the middle equation, right? If the base is unknown, we'll be using the last one. Or if the portion is unknown, we'll be using the first one, right? Because those are isolated at the left side. So you see, this is for the portion, this is for the rate, this is for the base. Let's try some problem here. Okay, so the question is what percent of 120 is 24%? Now, 24. The question is simple because you are looking for rate. Because the rate is not given, okay? Because you don't see anything with the percentage, right? But all you need to identify is which one is base and which one is portion. So, most likely with the word of followed by something with the word of is your base. The base is 120 to portion is 24. All we are doing is just applying the formula for the rate. Rate is nothing but the portion by base. We need the portion by base. If we apply the formula, we get the answer in fraction. And then we convert the fraction into percentage. Okay? We always get the answer in fraction and we convert it to percentage in such cases. Okay, let's look at another example here. The box of 240 squeeze was used to install the drywall. If the job is 75% complete, how many more screws are needed to finish the job? Now, first of all, you have to identify what are given. As you can see, the percentage is given, so your rate is there, okay, which is 75%. And the portion is given because the work is partially done. It's not complete yet. So whatever screws you needed, you had, those are used for the partial work. That is, of course, the portion, not the whole thing. Okay? So we have to find the base. So, and remember, any formula you use, the formula gives you the fraction, and also if you plug the rate into the formula, you have to plug it as a fraction. So that's why we convert we always convert the rate into fraction from the percentage. So the percentage is given as what? 75%. We convert it to fraction here, and we applied into the formula. We got 320. So this is your base. But if you read the question is not asking about the base. The question is asking about the difference between the base and portion. Because it's asking how many more you need. So you already used like 240. In total you will need 320. So if you just do the subtraction, you will be left with 80 more screws which will be needed for your meaning to complete the job. Any question here? Now we'll see how we can apply these formulas and try to find the rate, base, or portion. Let's see. Find 20% of 60. So the 60 is base, 20% is the rate. What are you looking for? Okay, first of all, which one is base? Of course 60. So the right answer is 60. Right? We just want to identify those parameters first. What is rate here? Of course 20%. Because rate is easy to identify because it should follow with this. It will follow the percentage sign. Will follow. What is the portion here? We don't know the portion, which is unknown, and we have to find it since this is unknown. So the right answer is B. How do you find the portion? Which formula we are using? We have three formulas, right? One for base, one for portion, and one for rate. Since the portion is unknown, we'll be using the formula for the portion. Which one is the formula for the portion? Exactly, the right, last one, right? The D. That is the right answer. So now, if we use it, B equals to B times R. The B is 60 and R is 0.2, right? Because remember we use the rate as fraction into the formula. If you do this, what will be the answer? 12, right? So the right answer is 12, right? Now let's try another example. What percent of 50 is 75? So 50 is what? The base or portion? 50 is base. Because most of the time base will follow the off, and as I said, the portion can be more than base. So the 50 is base, right answer is B. Okay. And 75 is of course the portion. And the unknown is rate. We don't know the rate here. So we'll be applying which formula here? Of course C, right? This is the formula for rate. So if I apply this, if we convert it to fraction, once I convert the fraction into percentage, then it comes to 100%, right? It's an improper fraction, right? And we converted that into, we just found the lowest term, 3/2. I think to be quick, you can just think like this. 75 equals to 3 times 25, right? 50 equals to 2 times 25 and cancel out 25. This is not probably the proper way because 25 is not prime factor. We used to write 5 times 5 times 3 and then denominator should be 2 times 5 times 5. Okay, so the right answer is 150%, right? So the right answer is A. Let's try another example here. What is unknown here in this question? I think of course the base, right? Because you see nothing is after of, I'm sorry, nothing is after the word of, so the base is unknown, so the right answer is B. Which formula we are going to use for this one? Base is unknown, right? So this is going to be the formula B. Base equals to portion over rate. So what is the correct answer here? What is the portion here? Let me give a pause here so that you can find the answer for this question. Okay, what is the correct answer for this question? What is the formula again? We are looking for base, right? B equals to what? P by R, right? So the P is 40 here, and the rate is 0.25, which makes it 160. Right? So the right answer is C. C is your base, which is 160. Okay, in the engineering discussion, a lot of times we try to find, try to solve a tolerance problem using the percentage, because a lot of equipments we use have some sort of tolerance. And it's already given in the question, okay, that, okay, let's say this is a register. The tolerance is 5%, okay, meaning, you know, it can go beyond or less 5 than what is mentioned. Okay, because you know any electric device or any other equipment we use in different engineering areas have some sort of specifications, right? They mention, okay, this can tolerate this temperature, blah blah blah. So in most of these cases, it doesn't be, it's not like exact what is mentioned. Most of the cases there is a tolerance limit. And it is also mentioned that the tolerance limit is 10%. That means whatever is mentioned in the specification, it can go more than that or less than that, but that is only within 5% range. So that's why it's important to understand the tolerance. And you know, as you can see here, the tolerance has a strong relation with the percentage, because those comes as a percentage. Now we'll see how we are using the, you know, so far what we did, we can use those to find the maximum or minimum range. Because as I said, let's say something is given like it can tolerate 30 degree temperature, let's say, okay? And it's also mentioned that it can also, you know, tolerate 5% less or 5% more. That means what? What would be the maximum temperature it can tolerate? 30 plus 5%, but how much is that? You can find that out. Or 30 minus 5%, how much is that? You can find that out. So that's called the range, minimum or maximum. Okay? What we do is, let's say we have a register which has 25 kilo ohm range. I'm sorry, specification, and it has 5% tolerance limit. Sorry? Kilo ohms. OHM. So that is the symbol we use for that. So let's say we are given 5% tolerance. Now how do I find what is the maximum resistance it might be, or what is the minimum resistance it might be? What we do is, we first convert it to fraction, of course, right? 5% we convert it to fraction, and then we multiply the 5% with the total resistance As you can see, the total resistance is 27 kilo, right? Which means 27,000. We multiply it with 27,000 with 5%, meaning 0.05. We get 1350, 1,350. What we do is we add 1350 with 27,000 to get the maximum. And we subtract 1350 from 27,000 to get the minimum. Now what does it mean? It just means that the resistance, even if it is mentioned that this will give 27 kilo ohm, it will not be exactly 27 kilo ohm. Instead, it will be anything within this range. But it can go as less as 25,650 or as more as 28,050. Because that's not in kilo.
It's already in, it's not.
No, it's not in kilo, right? It's just, we just wrote it as a ohm.
So we transferred it, the 5% transferred it?
No. We just wrote it as a ohm. You see, we have the symbol here. Kilo. Yeah, you know.
So where did the transfer
At the beginning,
take place?
that doesn't matter. I'm saying you can write as a 27,000 ohm in the original question.
Okay, so
Yeah.
using that same symbol does
Same.
not make
Yeah.
it possible.
But if you write kilo here, yeah. But in the original question, we could have given, we are probably given like 27,000 ohm. That is still the same thing. Yeah. So remember, this is your maximum range and this is your minimum range. In the question, you might be asked to find the maximum range or maybe for the minimum range. It depends, okay? Now, let's try an example here. I'll give you a pause so that you can find it. So what we have is we have 250 and this is the tolerance. Now can you find the maximum and see which one is the maximum from here? Okay, I'll give a pause here so that you can see. Alright, so what is the right answer here for the maximum? What do you do for the maximum? You have 250 and you add, what do you add? Remember, you multiply first 250 times the percentage, right? 250 times 0.1 here, right? Which is like 25. So to get the maximum, all you need to do is just add 25 with 250 and subtract 225 from 250. But here, a little bit tricky because as you can see in question in C and D, we added 25 in both cases. But the right answer is D. Because in C, we don't have units written. Because in all of the engineering, places, we need to write the unit. Because without the unit, 25 doesn't make any sense. We don't know that 25 is a kilometer, 25 is a mile, 25 is a meter. Okay, so it's important to write 25 feet. So that's why the right answer is C. 250 plus 25 feet, which makes it 275 feet, right? The right answer is D here. How about the minimum? The same thing, we just subtract 25 feet, right? So the right answer is C here. Minus 25 feet, which is 225 feet. So the right answer is C. Let's try another example here. 200 meter plus minus 5%. Plus minus 5% means the tolerance is 5%. Let me give a pause here so that you can try. Okay, so what is the right answer for the maximum? What we are doing? 5% of 200 meter, right? Which is 10 meters. So we add the 10 meter, right? So pretty much we are using which formula out of these? B, right? Yeah, 5% times 200, right? That's how you get 10. Remember, we first, yeah, we just wrote the whole thing in one line, just to show you that you can do it in the whole, So right answer is B, because this is like 5% times 200. So that's how you can get the difference, offset, and you add it to get the maximum. Remember, you can subtract it to get the minimum, right? Which is exactly the 10. So pretty much the maximum is going to be 210 meter. Minimum, if you apply the same formula but do the subtraction this time, it will be, right answer is D, right? So what do we need? If I write it in one line, what we need is this: 200 meter minus 5% times 200 meter. If we do this, it becomes 200 meter minus 10 meter, which is 190 meters, right? So that is your minimum range. That's how we get the right answer. So these are our examples. Now let's go to the pause, go to the quiz section, and let's finish all the quizzes for the chapter 4. So we have a test coming next class. Test will cover everything up to this point. In addition to that, test will have another lecture which is not a math problem, okay? It's about the professionalism. So what you need to do is, before you leave today, go to your pause after you are done with these quizzes, or maybe before you are done with this quiz. What you can do is go to pause, go to this class. Let me show you where. Go to the content section, go to the PowerPoints, we are just done up to here, right? Everything up to here, up to the percentage. Okay. Now let's do this. Let's first go to here, and then let's finish the quizzes. So for this chapter 4, we have 3 parts of quizzes. Okay. Let's finish all of these, and then we'll talk about that one. Okay.